Welcome to Sravz technical series. In today's session, we'll go over the Polaris data frame service. In today's session, we'll get multiple time series from the financial data service provider. Then we'll read that JSON we get from the service provider into Polaris data frame. Then we'll join the data frame on date time and then plot the data from these multiple time series. In today's session, we will get the Nvidia stock adjusted close price and the earnings surprise percentage, and then we'll merge these two data frames on the date time, and then we'll plot using matplotlib like this. So the advantage of this plot is we can see the earnings surprise based on the earnings. For example, here there was a negative earnings surprise, but the stock still went up. Recently there were positive earnings surprise, but the relative magnitude of the earnings surprise was smaller. Even then the market went up, and it could be due to the AI momentum. So once we have this data, we can do some analysis and see how the adjusted close price has changed historically based on the earnings surprises. So all of this code is done using Rust ticker plant code base, which I already showed in previous sessions. In today's session, we'll just update the Polaris data frame service so that we can get the earnings JSON file from the service provider and then merge the data frames and then save it to S3. The code is all here. We'll go through the code at the high level. We'll not go line by line because that would make this video very long. So before we go through the code, I'll just run the test cases to see that everything runs fine. I already generated the plot here using matplotlib. So the plot looks like this, which I showed in the documentation page. So we have the stock US Nvidia log adjusted close price on the y-axis and the date time on the x-axis. And then we have the bubble charts for the earnings surprise. On the Sravz website, if we go to the data and earnings, then earnings details, we see the data in a grid. So the goal is to put this chart down here so that we can visualize the adjusted close price along with the earnings surprises. So earnings surprise is represented by these percentages. The difference between estimated and actual is a surprise. So higher the percentage, that means the greater the surprise. Here there's negative 118%, negative 18%. That means there was a negative surprise. That means the estimate was 0.71, but the actual was 0.58. That was in 2022. And then we'll plot this percentage on top of the log adjusted close price. So I'll go to the code base and run some of the test cases. I'll go to the earnings service.rs. So if I run this, test get earnings JSON string. So when I run the test get earnings and provide a stock and the code like this, it will call the service provider and get us the data frame. So I just clicked on that. It's running the test, cargo test. So we have the earnings data frame here. Nvidia close, open, high, close, adjusted. So it is combined with the historical stock price. So we have the get earnings data frame there. We're getting some exceptions, but we can ignore that for now. Then we have other test cases like test get earnings JSON string. So it will convert the data frame into JSON and give us a JSON string. So we'll run that. I fixed the error we were encountering. Now I'll run the get earnings data frame test again. We're going to have Nvidia results in a couple of days. So the service provider added the date, but they have put nulls for the percentage value. So that was throwing an exception. So I updated the code now. It will ignore the data points if there's a null value in the percentage. Now I'll run the test again. Get earnings. So now the test runs fine. Running one test get earnings. It's okay. So it ran fine. We got the historical results. Then we got the earnings data frame, report date, difference percent, which we saw in the UI here, percent. So we get that data frame. Then we join those two data frames on the date time, and then we'll get a common data frame with the historical prices and the earnings. Once we get that data frame, we'll save the data frame as a Parquet file, and then we'll use that Parquet file in Python to display the plot. I'll go to the test case where we create the Parquet file. Okay, test get earnings Parquet file. We'll run that. So this test will create the data frames, join them, creates the Parquet file, saves it to S3, and then we also get the path where the Parquet file is. So this is the Parquet file we generated of the joined data frame. Then we'll go to the earnings.py file. We will read the Parquet file, and then generate the plot. I'll go to the terminal where I generated the plot like this. Then when I run this command, earnings.py file, it creates the plot.png file, and the plot.png file contains the adjusted close price for Nvidia and the earnings price like this. And that's how we generated the plot which we have in the screen here. Now for the code, I attached the Rust code I've used. So we have AWS S3 service, data frame service, earnings service, and then we verify the output. So in the data frame service, we have various functions like data frame to JSON file. We get a data frame from the service provider, we get the JSON file, and then we'll use S3 decompress that JSON file, which is in GC format, and then we'll generate the data frames off of that time series. Similarly, we have saved data frame to S3. So we'll convert the data frame to JSON string, and then we'll save it to S3. And then we get earnings data frame. Get earnings data frame will use a REST client. So we have REST client. We'll do HTTP get the results, and then convert the JSON into data frame, and then returns the data frame. And these are the various test cases for the code base I just showed above. Then we have the earnings structure, which implements new and then get earnings S3 URL. This will give us the S3 URL where the data frame data, where the earnings data is saved. We convert the JSON data into a data frame, and we get the earnings data frame. And this one also joins the historical data frame. So this way we'll get both the historical and the earnings data frame joined on the date time. So we have earnings data frame. We have joined data DF results, which is a join of date time and report date time. So it's a join DF, and then we return the join DF. We make some column name changes, calculate the percentages like 3-month percent change, 1-year percent change, etc. And then we return the data frame, lazy data frame dot clone. So these are the test cases for the data frame. Then we have S3 module which has various functionalities like create bucket, list objects, etc. We discussed this one, so for today I'll skip it. We also have a function to generate pre-signed URL, compress string, etc. So that is the S3 client. So you can go over this code in the code. You can go over this code in this URL, or it is also uploaded to GitHub as a gist. And then we have various test cases. So with that code, we were able to generate this graph. In the next session, we will show this graph in the Angular client here. So we'll just put that plot underneath this, and then we'll plug in the UI so that the UI calls the Rust service, and the Rust service will generate the plot in real time and then sends it back to the UI using WebSockets, and then we'll display it here. So in the next session, we'll go over that Angular code base, and then we'll see how we integrate Angular with the backend service. With that, I'll close today's session. If you have any questions or comments, please reach me out in the YouTube channel or in the discussion tab here in the documentation page. Thank you for watching.